So for homework, we're going to try something a little different. And what I want you to do in this assignment is to take notes on what I'm talking about. So attached to this podium assignment, you'll find the PDF that has all the slides in it, and you're going to want to print those out. And you can follow along with what I'm doing and take notes. In the notes, I'm expecting you to highlight. I'm expecting you to write out all the notes and the examples. I'm also expecting you to write any questions you may have about what I'm showing you for today. So this is a little bit of a review from what the problem in class was, which was problem 3.2, and it's moving forward a tiny bit into problem 3.3. Now, when you get to class on Wednesday, I will give you for classwork problems that are similar to these notes and similar to this lesson. So hopefully it'll be independent work that you can do on your own. So think of this as the learning, and when you come into class, that's going to be the practice time. Okay? So the first problem says, getting ready for problem 3.2. The equation 85 equals 70 plus 15 states that the quantities 85 and 70 plus 15 are equal. So we have our equation here, and what it means is this piece and this piece are equal to each other. Right? And it says, what do you have to do to maintain equality? Now, maintaining equality means we're keeping the equality, right? We're keeping the equation balanced. This is one of those tricks that we talked about when we were solving multi-step equations. Whatever you do to one side, you have to do to the other side. So you're keeping the equation balanced. So if you subtract 15 from the left-hand side of the equation, in order to keep the equation balanced, we have to subtract 15 from the right side of the equation. And it seems simple, it seems obvious, but that's what these questions are asking you. If you add 10 to the right-hand side of the original equation, in order to keep it balanced, you have to add 10 to the left. If you divide the left-hand side of the original equation by 5, well, you have to divide the right-hand side by 5. Okay? And the last one says if you multiply the right-hand side by 4, then we have to multiply the left-hand side by 4. Okay? So it says try your methods on another example, summarize what you know about maintaining equality. We know this, right? We're going to try an example. This is the example that we did in class for some of your classwork. And the story's set up, and it says, in the kingdom of Monterrey, the ambassadors carry diplomatic pouches. The contents of the pouches are unknown, except by the ambassadors. Ambassador Milton wants to send $1 gold coins to another country. His daughter Sarah is a mathematician. Ooh. She helps him devise a plan based on equality. That's one of the concepts that we're talking about, right? Keeping equations balanced. To keep track of the number of $1 gold coins in each pouch. In each situation, each pouch contains the same number of $1 gold coins. That's crucial. That's the most important thing that we need to know when we're looking at these types of problems. The number of gold coins on both sides of the equality sign is the same. But some coins are hidden in the pouches. So some coins are hidden, but the number is equal. Try to find the number of gold coins in each pouch. So there's a few things here that we need to know. One is that in each pouch, the number of coins are equal to each other. So we can use the same variable to represent that quantity. We also know that this side of the equation is equal to this side. So whatever we have on the right-hand side is going to be equal to the left-hand side. So question B says, for each situation, find the number of gold coins in the pouch. write down your steps so that someone else could follow your steps to find the same number of coins in the pouch. Now, this is going to be an interesting process. But what we first need to do is figure out how many coins are in the pouch. And the way to do that is to remove everything but the pouches from the left side of the equation. What I mean is, if I take away 3 gold coins from the left side of the equation, all I have left are the 3 pouches. So it would be easy for me to divide whatever the number of gold coins is by 3 and figure out how many are in each pouch. But the rule is that whatever you do to one side of the equation, you must do to the other side. So I have to take away 3 additional gold coins from the right-hand side of the equation. Now that those are gone, I have 3 pouches, and I need to know how many of the coins are in each pouch. Well, that's simple. At this point, I just need to know how many coins I have left on the right-hand side of the equation. I have 1, 2, 3 here, and then I have a span of 4 by 6 pouches. Coins. So 6 times 4 gives me 24. 3 from the top row gives me a total of 27 coins. If I have to divide 27 coins evenly amongst 3 pouches, how do I do that? 27 divided by 3 equals 9, which means I have 9 coins in each pouch, or x, my variable, is equal to 9. How do I check my answer? This is simple. I just want to think, okay, if I have 9 coins in this pouch, plus 9 in this pouch, plus 9 in this pouch, plus my 3, it needs to equal however many coins are on the right-hand side of my equation, right, in this piece. And that piece holds 1, 2, 3, 4, 5 coins by 1, 2, 3, 4, 5, 6. So that side of the equation is equal to 6 times 5. So 6 times 5 is easy, that's 30. Should be equal to 9 plus 9 is 18, plus another 9 is 27, plus 3 is 30. Well, 30 is equal to 30. This is true, which means that the number of gold coins in each pouch is truly equal to 9. Now, part C said describe how you can check your answer. That is, how do you know you found the correct number of gold coins in each pouch? Well, we just checked it, right? We figured that out. Part D wants to know, describe how you maintained equality at each step of your solution. Well, the way we maintained equality is whatever we did to the right side, we made sure we did to the left side. Right? And it's important that you understand that the equal sign is the middle. It's the balancing part. So whatever you do to the right side of the equation must be done to the left side of the equation in order to keep it equal.